Okay. Okay. Now let's look at a, um, deeply at this probability of accepting. Okay, minus delta E by T. Now we have two types of problems. Sometimes our objective can be finding a maxima. Sometimes our objective can be finding a minima, right? So in a curve, I may want to find a maximum or a minimum. And we know this strategy that we just learned in the past previous video helps us find a global maxima or minima. Now, if we define our delta E as E new minus E old. So old is the original, new is the neighbor that we created. When I want maxima, okay, my new to have the E here is the objective. Okay, so let's say I want to find the maxima. The original solution's objective value was 20, new one is 22. So if I'm finding a maxima, this is actually a better solution. So I have to always accept it. If I'm finding a less value, the neighbor has a worse solution, so I have to accept it with a probability. So in such case, our equation, when I get better, exponential negative of this 22 minus 20 is a positive value. So in some negative, if delta is positive, this whole thing will be a negative by t. So in that case, when I want to find a maxima, if I use exactly this equation, I am actually again getting a probability value. But originally, because I am looking for a maxima, I should accept this. I should always accept this. So this should be greater than 1 all the time, so that by default, I'll just accept it. You see, if I'm finding a minima, this equation works well because I do not want a higher value. So whenever I find a higher value, 22 minus 20, which is 2, and a negative sign ensures that I get a minus 2 divided by whatever value. This acts like a probability. But if I am finding maxima, I do not want to accept a higher value with a probability. So what I do, there are two ways of solving maxima. One, multiply the function itself with a negative value. Then the function just gets flipped over. So then you find a minima. So either you find maxima of fx or minima of minus of fx, right? That's one strategy. In fact, the most common strategy. But sometimes you see me doing something else. When I want to find maxima, I change the probability equation to I remove the negative sign. Now, let's say the neighbor has 22. This becomes a positive value, and this whole thing then is a positive value. So always this is accepted. When it becomes a 19, 19 minus 20, this becomes a negative value. And between 0 and 1. So I accept this with a probability. So these are the two ways of solving maxima minima, in particularly maxima minima. The equation that we learned, exponential minus delta E by kt, works, and it always tries to take you to the lower value. Always lower value is accepted if the neighbor has a lower value. If it has a higher value, it's accepted with a probability. If I'm finding maxima, one way is multiply with a negative and do the minima. The other way is remove the negative sign in the exponential so that higher values are always accepted. Whenever I get a neighbor in lower value, it's accepted with a probability. Okay, so just wanted you to know that nuance.